Hello dear students, and we are back again to keep solving and keep explaining chapter 4 and section 3, heat and work. And the last video we have solved question 1, and now we reach in question 2. Question 2, the question said a gas enclosed in a container and with a piston, the applied pressure is maintained 599.5 kilopascal. This is the pressure. Let me write down here. Okay. So the first pressure in here that we have P1, 599.5 kilopascal. The piston moves inward. We change the volume of the gas from this to this. How we know which one is the first volume and which one of them is the second volume? In this topic, which number that came the first, this will be the first volume, and which one and it came the second, this will be the second volume. So it means this is the first volume, 5.370 times 10 power negative 4. This will be the first volume. V1, which is equal to 5.37 times 10 power negative 4, and the second volume that we have, the second volume, to 2.523. This is the second volume. 2.523 times 10 power negative 3. The question said how much work is done. So find W work. And I think it's pretty easy question. So yellow, we have a relationship between volume and pressure. So we have to apply which rule? This rule, that one. W equal to P delta V. In here we have 599.5. In here we have by kilopascal. How we can make it kilopascal to pascal? By multiplying 10 power 3. So instead of pressure, write down 599.5 times 10 power 3 and multiply and open this bracket. Delta V, we can write down V2 minus V1, the second volume minus first volume. 599.5 times 10 power 3 times, and the second volume is 2.523 minus 5.317. Students, in here, because both of them they have 10 power negative 4, we can't take this 10 power negative 4 outside the bracket. You can't write down in here 10 power negative 4 because both of them they have same number. You can't take it out next to the bracket. You can minus this number, and the result multiply. So the value and the answer of this question, will be negative 1.167.5 joule. Question 3. Question 3, same thing. Question 3, look, you can do it by yourself. It's so easy. And same thing. Question 3, a toy of balloons inflated with a helium constant pressure. This is the pressure, and exceeds its atmospheric pressure. If the balloon inflated from this volume to this volume, this is the first one, this is the second volume, how much work is done? Let me solve it. It's okay by myself. It's okay. This we have the pressure 4.3 times 10 power 5, and this is question 3 answer. The first volume, because in here which number it came first? First we have this number, so this will be the first volume, and that one's become the second volume. Good. V1, which is equal to 1.8 times 10 power negative 4, and V2 equal to 9.5 times 10 power negative 4. Find work. Yalla, again we have PV, we have pressure with volume. Again we have to use the same like question 2, P delta V. So P in here we have by Pascal, so it doesn't necessary to convert, leave it like that because already by Pascal. 4.3 times 10 power 5 times, and instead of delta V we have to minus V2 minus V1. 4.3 times 10 power 5 times, as I told you again, both of them they have same power, 10 power negative 4. You can write down outside of the bracket 10 power negative 4 times and minus both of them. The first one we have 9.5 minus 1.8. Let me minus for you. 9.5 minus 1.8. 9.5 minus 1.8. The answer is 7.7. And 7.7 times by 4.3. Times by 4.3. This will be 33.11. 33.11. And 10 power 5 with 10 power negative 4. Only 10 is left. It will be 10 power 1. And this number times 10 will be 331.1. So this must be work, not pressure. So this will be by joule. Okay, question 4. You can do it by yourself. Same thing. We have another topic, which is called the thermodynamic process. Guys, this section I'm going to summarize for you. In here we have 3 types of thermodynamic process. We have isovolumetric process, isothermal process, adiabatic process. This is the 3 types of thermodynamic process. I'm going to explain one by one. Isovolumetric process. In isovolumetric, by the name you can memorize. Isovolumetric, it means thermodynamic process that take a place of constant pressure and that no work is done. Yeah, in general, we can make it brief. I can summarize for you now. In isovolumetric, because we have volumetric, it means that volume is 0 with work. Both of them changing volume and work, delta V and work 0. Volume and work 0 or stable. Isovolumetric take a place of constant pressure. And there is no changing. As I told you, the relationship between volume and work directly proportional. Because volume 0, it means there is no work done. Because volume is 0 isovolumetric. In this first type of isovolumetric, no work is done. No work is done at constant volume. No work is done by the system. Such a process is called isovolume. And isovolumetric, no work is done because changing volume constant or stable. The second type in here that we have isovolumetric process. Isovolumetric process, again a thermodynamic. Because we have isothermal, thermal يعني delta T يعني changing in temperature 0. Look, changing in temperature 0 with internal energy. Look at the definition said what? A thermodynamic process that take a place at what? Constant temperature. Constant temperature. Take place of constant temperature, which internal energy of a systems remain unchanged. يعني temperature constant, temperature won't be changed, and even though the internal energy too won't be changed, both of them 0. Changing in temperature and delta U, changing internal energy, both of them 0. Temperature constant and internal energy going to be both of them 0. Isothermal, it means delta T isothermal, يعني temperature won't be changed 0, and even though at the same time changing internal energy too will be 0. In this process, the system is going to be happen gradually, يعني step by step. Now we have studied 2 of the type, isovolumetric. We said in isovolumetric there is we don't have changing in volume because delta V is stable or constant, won't be changed, يعني there is no work is done. The second one, isothermal. يعني changing in temperature, constant, stable, because change temperature stable, changing in internal energy will be stable too. Both of them at the same time won't be changing, and both of them delta T and delta U 0, and it happening gradually. The last type of thermodynamic process in here that we have adiabatic process. In adiabatic process, a thermodynamic process during which work is done. We have work by the system, but no energy transfer. يعني we have delta U, we have work it's done. We have work done, but there is no transferring energy. Q0. There is no transfer energy, but we have work is done. We have work, but there is no transfer energy. Look, energy is 0, and this steps happening during rapidly, but the other isothermal, it was gradually. You have to memorize Ligon in this property because for exam and for multiple choice really important. Section reviewing. We reach section reviewing. In section reviewing, we have in the first question here, we have the question said, in which of the situation listed below, the energy being transferred in heat to the system in order for the systems to do work, and which of the following work being done to the system? The question said, in which one of them first work is done, then you have transferring energy, and in which of them first you have transferring energy, then work is done. Let me explain one of them for you one by one. In which one of them we have to explain by ourselves one by one. For example, it's part A. First is first work is done or energy transferring? We have to answer like this. We have two sticks are rubbed together to start a fire, and when you have two wood or two tree, we will do like that to make a fire. First of all, we have done work. We have done some work. I have done some work now. After that, we can make a fire. And first we have done work, then we can create fire. When the fire is created, then we can and first we have done work, then between our hand there is transferring energy, then it can create a fire. So first of all, two sticks are rubbed together to start a fire. First work is done on the two sticks, then we can make a fire. So first work is done. Part B, a firecracker. Firecracker, for example, in every new year, especially at the last month when it become at 12 a.m. When every people they are celebrating for the new year, in the sky they are throwing this this game is called firecracker when the sky is going to be shine and brightness. This is called firecracker, tontraqa. So this firecracker, first of all, for example, imagine this firecracker. Inside the firecracker, energy is transferred between inside this firecracker. There's transferring energy. After that, the firecrackers explodes. And first inside there is transfer energy, then fire explode. First you have transfer energy, then work is done. Transfer energy, then work is done. So in part B, in firecracker, how is work? Energy transfer as a heat, then which does work when it explodes. The last one, a red hot iron bar is set aside to cool. For example, I'll leave this if you don't understand. For example, we have a tea or ice or tea or coffee, some liquid that they have a hot temperature. Before to drink it, you can leave it in here. After 1 hour, you see that the temperature of this liquid or this tea become decreases or become cold. Why? Because this tea, they are transferring energy from the higher temperature, the tea they have higher temperature, to the lower temperature, it means to the air. They are transferring their own energy from the high to low. That's why with time, they are losing their energy. So the temperature of this tea become cold, become decreased. So in that case, we haven't done any work actually. Only we left the tea, for example, in here on the table, and they are transferring their own energy. They are losing, they are releasing their energy without doing anything. So we haven't done any work. So in part C, only there is transferring energy in part C. Okay. Question 2. Identify the following process. Which one of them like identify, for example, part A, is it isothermal or isovolumetric or adiabatic? Part A, we have a char being rapidly inflated. As I told you, if we have rapidly, it means this type is adiabatic process. Part B, a tear expanding gradually. We said if you have gradual, it means isothermal. This is isothermal. A tear being heated while in a rigid metal container, because you have container it means volume, so this has become isovolumetric. If you have rapidly, adiabatic. If you have gradually, become isothermal. The other one, containers, become isovolumetric. Students, we finished chapter 4 section 3. Now we reach in chapter 4 review and assess. Chapter 4 we have some questions, so now I'm going to explain only the important question, and as you know, like the previous chapter, because there is a lot of question. Now look, and take so many times if to explain all of them, so I'm trying to explain the important question actually. Good. Question 1. Let me start from the question 1. Question 1 said, what is the relationship between temperature and internal energy? Of course, we explained that relationship between of them direct proportion. For example, if we have an object container, if they are receiving a lot of energy, a lot of temperature, the temperature of the particle going to be increase, and the internal energy become increased too. Because we explained what is internal energy. Internal energy is the motion of the particle. When the particle they are receiving energy, of course they are moving so quickly, and the motion of the particle getting increased. So it means in general, relationship between both of them are directly proportional. So question 1, we can say like that: if the temperature increases, internal energy increases too. Question 2. What property of two objects determines if two are instead of thermal equilibrium? We said one of the most important property in thermal equilibrium, we said that both of the objects, TF, temperature, T final temperature, both of the objects they have same temperature. So the most important topic that the most important property that they have, their temperature are same. This is the property of thermal equilibrium. Their temperature are same. Question 3. Which drawing in this figure correctly shows the direction in which the net energy transferred by heat between of them? We have this cube and we have this freezer wall. This freezer wall and this cube. Which one of them shows the correctly direction of transferring heat? If you know that the temperature for both of them is -10, -10, -10, -10, -10, -10, -10, -10. You know which one of them is the correct answer? You have to know. This is so easy, actually, important. Part B is the correct answer. A and C, both of them are wrong. You know why? Because you should know actually. Even I told you, you have studied. If both of the objects they have same energy, same temperature, if they have same temperature, both of them -10, actually in that case we don't have transferring energy because both of them they have same temperature. So part A, it's wrong. It's wrong. In here it's written, they told us in here, it means like that we have transferring energy from right to left. Actually this is wrong because both of them they have same temperature, so there is no transferring energy. It's the same thing. The question means that you have transferring energy from left to right, but still it's wrong. Part B is corrected because there is no direction and there is no transfer energy because both of them they have same temperature. Question 4. Question 4. A glass of water has a temperature 8 Celsius. In which situation will more energy be transferring when the Earth's temperature 25 or 37? Of course, the bigger temperature. If you have a glass of water, their temperature is Celsius. In which of the situation will more energy will be transferring? Of course, because we have transfer energy from the higher temperature to lower temperature, right? In which one of them that you have more transfer energy? The bigger temperature, 35, that you have more transfer energy. Question 5. How much energy is transferred between a piece of toast and an oven when both are at temperature of 55 Celsius? The question said how much energy that you have transferred in between these two objects when both of them they have 55 Celsius. Actually, none of them, because we don't have transfer energy, because both of them they have same temperature. Both of them they have same temperature. Question 3 answer. Question 3 answer. It was B. And question 4 answer. The number was 35, and question 5 answer none of them. None of them. Question which one else? What else? Let me solve some of the question here. Look at question 13. Good question. In which of the two situations described is more energy transfer? Again, a cup hot chocolate with a temperature 40 Celsius inside negative 20 Celsius. Same cup of hot chocolate 90 Celsius at room on 25 Celsius. Which one of them? Actually, the answer, the second situation, because the difference in temperature is more. Which one of them that they have more difference in temperature? Part B, second situation, between 90 and 25, we have more different temperature between 90 and 25. So of course, part B is the correct one because we have more difference in temperature between of them. Because the difference in temperature more. Let me solve some of the example that we haven't solved before, but only we explain the rule. Question 14 said we have this number by Fahrenheit, this temperature, converted or changed to degree, then Celsius and Kelvin. How we can convert this? Look. So that the temperature of the question 14, the temperature of the question 136 Fahrenheit. Convert to Celsius, then Kelvin. Then how we can first make it? First, what was the rule? The rule of let me write down the rule. The rule, it was T. We have two rules. TF equal to 9/5 TC plus 32, and this is TC equal to 5/9 and TF minus 32. That's why I wrote both of them. Maybe you're getting confused, Mr. Why in here we have two rules? Actually, there's only one rule, but this is the general rule. TF equal to 9/5 C plus 32. But the question said make this Fahrenheit, and in here we have by Fahrenheit. You have to change and convert to Celsius. Immediately use this rule, because if you are using this the first one, you have to arrange the equation. Or maybe it takes time and you'll do mistake maybe. So directly use this one. Okay. TC, the temperature by Celsius that you want to find it, 5/9 inside the bracket. The temperature by Fahrenheit we have 136 minus 32. First of all, minus this two number, 132 minus 32, 136, sorry, minus 32. The answer, 104. And 104 times by 5/9, times by 5 over 9. The answer will be 57.7 silly z. يعني first minus this will be 104. They multiply by this fraction. This is the answer by silly z. And one thing that's left, this by silly z. The question said even though make it 2 Kelvin. Make it 2 Kelvin. How we have to make it 2 Kelvin? Even we have another rule. T Kelvin, which is equal to TC plus 273. Yalla, use this rule. We found the temperature by silly z 57.7 and plus it with 273 and plus both of them. The answer will be 330.8 Kelvin. This is by Kelvin, the answer. Good. This is the answer of question 14. Question 15, the same thing. Question 15 again, like question 14. We have this by Fahrenheit, make it Celsius and Kelvin, same. Question 16. Question 16 or question 17. In question 17, this is a good question we have. Look, question 17. The question 17, the question said a 0.75 kilogram spike is hammered into a railroad tie. Look, so in here we have this question. A 0.5 kilogram, so this is the mass of the spike, mass equal to 0.75 kilogram, hammer into a railroad tie. The initial speed of the spike equal to 3 meters per second. The initial speed of the spike equal to speed v equal to 3 meters per second. If the tie and spike together absorb 85% of the spike kinetic energy as internal energy. Look, absorb 85%. Look, you know what I mean? Absorb 85%. Yani write down 85%. 85% what? 85% the spike initial kinetic energy. Yani 85 ke, 85 kinetic energy as a internal energy, يعني like internal energy, يعني equal to internal energy, يعني 85% kinetic energy like internal energy. The question said calculate the increase on internal energy and find delta U. Yalla, first of all we have solved this before, I think. Yes, convert 85 to decimal number will be 0.85 times, and instead of kinetic energy write down the rule 1 over 2 mv squared. If you remember, we have studied this rule, delta U. So 0.85 times 1 over 2 times the mass of the hammer, the mass of the spike, a 0.75 kilogram spike is hammered, 0.75 times the velocity. Even the velocity in here, if we have this is 3 squared. 0.85 times 1 over 2 times 0.75 times 3 power 2, it means 3 times 3 will be 9. Calculate all of them. 1 over 2 يعني 0.5. Multiply all of them together. 0.5 times 0.85 times 0.75 times 9. The answer 2.868. So delta U will be 2.868 joule. This is the answer of question 17. Question 18. Where is question 18? The question 18 said, what data are required in order to determine the specific capacity of unknown substance by means of calorimeter. The question said what data are required. You know what the meaning of this question, what data are required? It means in general, find the factor that can affect specific capacity. What was the rule of specific capacity? Cp equal to Q over M delta T. So the answer is energy, mass, and changing in temperature. This is the data to find or to determine specific capacity. Yani first, the answer is Q or heat, and the second, mass of the object. The third one, changing in temperature, temperature or temperature changing. Because the question said what data are required, What data are required in order to determine specific capacity? The data that in here we have to find specific capacity in each of the question. In any of the question, we need Q and we need mass and we need delta T. This is the answer. This is the answer of question 18. Question 19. Question 19. What principle permits calorimetry to be used to determine specific capacity of the substance? What principle? Conservation of energy. This answer conservation of energy only. Not important. We have solved actually important question. Question 26 is, just let me tell the idea. Question 26 and we solved a question like that. It was in section 2 reviewing. We have solved the graph. If you remember, when you have the graph, the curve, to find the specific capacity for each of the part, latent heat fusion. I told you the idea. It's the same thing. Question 31, the question said define thermodynamic system and environment. We have studied this. Question 32 said, in what two ways internal energy of the system can be increased? One of the way that I told you by deforming. We have so many ways to increase internal energy of any of the object. One of them by increasing by deforming or by adding force, by shaking, by so many things. But in the key answer of the teachers, it is written like that. Energy transferred to the system as heat and work. Question 33 is so important. Even I told my students, be careful about question 33. Question 33 is so important. Question 33, it said, just focus with me. Question 33, which of the following expressions have units that are equivalent to the unit of the force? Yani it means which one of them that they have a same unit of work. First of all, we have to know that the unit of work which is equal to joule, the unit of force of work. In here, the unit of work, we know, and I told you that the unit of work every time, joule, which is equal to joule. So which of the following expression have unit, yani which one of them, they have same unit like work? First of all, you should know the unit of work is joule. Which one of them, which of the part that their unit are joule? The question said, are equivalent to unit of joule. Yani which one of them in general they have or their unit are equal to joule. First of all, let me check part A. Part A, in here we have mg. Actually, mg, this is this rule. The unit of mg. It's not equal to joule actually, because Fg, this is the rule of force, because force equal to mg. So this is not equal to, unfortunately, this unit is not equal to joule. This is incorrect. Part B, 1 over 2 mv squared. And now we have solved the exam about this. This is the rule of kinetic energy. And kinetic energy, the unit of kinetic energy is which is equal to joule. So part B is right. Part C, mgh. mgh, this is the rule of potential energy. And potential energy, this is still, they have same unit like work. This is the unit is R equal to joule. FD, this is the rule or formula of work. So work unit, of course, this is joule. So this is right too. P delta V, this again rule of work. So this still it's right, but part F it's wrong. So the answer is B, because B 1 over 2 mv squared is kinetic energy. This is correct. It's joule unit. And part C, mgh, this is potential energy, and the potential energy unit is still is joule. So C is correct. And the part D, FD, which is equal to work. This is the rule of work, and work still again is joule. So part D is right. And part E, same thing. This is again same. This is again the rule of work. So work again, they have units of joule, E. So the answer B, C, D, E. B, C, D, E. Okay. Question 33, it was important. So in general, the question said which one of them that they have same unit like work. First of all, you should know the unit of work is joule. So part A, it was unit of joule, and part not part A. Part B, it was joule. Part C, it was joule. Part D and E. Question 34 important too. For each of the following, which thermodynamic quantity have value equal to 0? Which one of them? Which quantity for each one of them that equal to 0? First of all, in isothermal, we said which thing is that equal to 0? We said delta T, right? Delta T and delta U equal to 0, if you remember. And adiabatic, in adiabatic, we have said an energy. There is no transfer energy, so Q equal to 0. And in isovolumetric, by the name isovolumetric, يعني delta V equal to 0, and even though work equal to 0 too. So in isothermal, delta T and delta U 0. In adiabatic, there is no transfer energy, so Q 0. And isovolumetric, changing in volume and work, both of them are 0. I think it's enough. Finish, students, and we finished it, even though chapter 4 all. Inshallah, for the next video, we will start to explain chapter 5. Thank you for all, and I hope you can get benefit from all those videos that I have done. Thank you for all again, and have a nice day.